Hello and welcome to solving equations, quadratic equations specifically by completing the square. Yay, we're so excited, woohoo! So, the first thing you have to remember is what is a perfect square. So a perfect square is any number times itself, yes, but it's also any value times itself. So 4 times 4 is a perfect square, but so is x times x, and so is x minus 3 squared. And anytime you can write something squared, it's a perfect square. Okay? So when you're solving an equation that has a perfect square in it, there are a couple ways that you can solve this. Okay? This particular one, actually all of them. However, we're going to go over taking the square root, doing the inverse operation. So the inverse of x squared here, the inverse of a squared is square root. So that's what we use to get rid of the 2. Just like when you're adding in an equation, you subtract to get rid of it. They're inverse operations. It's an important concept. Will come up all the time in this class. So the moment you take the square root, you have to remember that it can be both plus 5, but it also can be minus 5. Because remember, negative 5 squared is 25, as well as 5 squared is 25. So remember, there's 2 is the exponent, so there's probably going to be 2 answers. Okay? So then we look over here, x squared equals 32. Oh no, not a perfect square. What do I do? Well, you just do what we did yesterday, was you simply do plus or minus the square root of 32. But you do need to reduce because, higher math, got to do stuff. So the square root of 32 can be broken down into 16 times 2. Remember, the biggest perfect square is 16. Others go into it, but then you'd have to break it up more. So x equals plus or minus 4 radical 2. So that means plus 4 radical 2 is one root, minus 4 radical 2 is the other root. Over here, this one now gets slightly more interesting because x minus 2 squared equals 44. So this one is can throw you sometimes because you might think that you have to actually multiply that out. But the whole process that we're going to be doing today is getting it into this equation where we have a perfect square equal to a value. So that all we have to do is take the square root and the square cancel themselves out, and I'm simply left with x minus 2 on one side and plus or minus radical 44 on the other. And that's it. We do have to then solve for x. That's like the hard part. After that, you reduce the square root of 44. So I'm going to take it up at the top a little bit so you can see, just so that I can show my work a little. So it's 4 times 11, so it's 2 radical 11. So add 2, and x equals 2 plus or minus, and then this radical 44 is 2 radical 11. Okay, so it's a lot involved, but the basic idea is, just like in every single one of these, you take the square root to get rid of the squared, do it with both sides. You get plus and minus. Okay, and if there's anything left on this side, you simply have to move it over to the other side. So we have to get x by itself. So we subtracted 2, so we're going to add 2 to the other side. Okay, so now, anytime you do remember, anytime you put a square root on an equation to solve it, so I had to put this square root on to solve it, I have to put this plus or minus because I have to take into account the idea that whenever you square something, it's positive. Okay, So when we're looking here, when we're doing perfect squares, our basic idea behind solving something with completing the square is we want to get a perfect square. So we want to get x minus 2 squared. We want it to look like this. Now these are what I call, patent pending, hidden perfect squares, because they are perfect squares if we factor them. So if we factor this out, and this is x plus 4, okay, you see that that's the same as x plus 4 squared. It's an important concept. It's hidden, okay? So this one, in the end, if you want to pause it for a second, see if you can figure out what the next 3 hidden perfect squares are, here, here, and here. Figure out what can be written like this. Okay, take a second, pause it, try it on your own. It's a good idea. Okay, now that we're back, this one looks like this. In the end, this one looks like this. Now you can factor it, but they all follow a very, very special pattern. Shocking. Okay, they all follow a special pattern. Can you find the pattern? I don't know, I'm in a video. So this is this right here is negative 6x. This number right here is negative 3. If you look, can you find a pattern between this number and this number, this number, this? They're half. It's half. So when you're creating a perfect square, this number is always half of the b term, or the number with the coefficient with an x. Always half. So half. This number right here is always that number we made squared. Every single time. So it's half square, half squared, half squared. Woo! So if you come down to the bottom here, okay, I could do that, or I could actually move it. If you come down to the bottom here, you can see we can create a perfect square, and that's what we want to do. We want to find a number to add to a binomial of sorts. So this first one is a binomial, right here. This is a binomial. So if we take 8 and divide it by 2, that's the perfect square that's going to be using it. But what number would that have to be if the answer was x plus 4 squared? Okay, so that's what I'm looking for. The value to add to the following expressions is that 16, and the actual perfect square is x plus 4 squared. So let me just do one more before you pause it. Okay, so what am I going to add? Well, you know what? I really don't know. All right, I need this step right here to figure out what goes here. Okay, so all I do, look at this number, half. Bam. Then take this number, square it, there. Perfect square. If I were to factor it, it's a hidden, this guy is right here, is a hidden perfect square, and this one right here is the actual perfect square, a value squared. Okay, take a second, please pause it, try it on your own, see if you can figure out what goes here and figure out what goes here. Thank you. All right, I'm going to switch to green. So now that you've done all these on your own, let us fill in the blanks to get the answers. Okay, I'm switching to green. So half of this, 5, square it, 25. Oh no, it's odd. So half of this, 5 over 2. Now you can write 2.5 if it makes you feel better. However, we like fractions more. So leave it as 5 over 2 unless we tell you where to round. Okay? So 5 over 2, and then this right here, square it. So whenever you square a fraction, just square the top, square the bottom, and you're good. Excuse me. So that should be a 4. And that's squared. Okay, I'm going to write it down here. So what do I square? Oh, I just take this, divide it by 2, and you just divide it by 2. That's all you do. Bam, it's divided by 2. Then up here, you just square the top, square the bottom, done. Over here, this one was easy, because it's even. Even is easy because you can divide even things by 2. And then here, so this number in here, take this, half of it, 8, square it, 64. Beautiful. So if you got that concept down, the half square, half square, half square, you got this. This is nothing. You're going to have a great... Alright, so let us try to solve equations by completing the square. So what we're doing is we're putting all of those steps that we just did together. Taking the square root, putting the plus or minus on, doing the half and the square to complete the square. These are all the things that we're going to do, and we're going to put them all together. So there's a few things that you have to be aware of when you're doing completing the square. First thing is the leading coefficient must be 1. So if you look here, the leading coefficient in this guy is 2. So it can't be 2 there. You can't have a 2. That guy has to be 1. So luckily for us, this one, if I divide everything by 2, I eliminate it. And when I divide everything by 2, I don't get fractions, which makes us all very happy. Okay, when I divide 0 by 2, I get 0. So I'm going to solve this now by completing the square. So leading coefficient is 1. Leading coefficient is 1. The second thing is letters, or we call them variables, and numbers, not a hashtag, it's just a number, are on opposite sides. And then you have to solve. So these things you have to be sure of are done first, and then you solve using completing the square. So the fact that our leading coefficient is now 1, that's good. But now letters and numbers need to be on opposite sides. So these two have letters, okay? And this has a number. So they need to be on opposite sides of that equal sign. So the x's are together, that's great, but the number has to move. So when I move it, I add 4. Stylus is going bad. So I add 4. So I'm left with x squared minus 2x. And you don't know this yet, but, well, you might. You've done this already in your life. You have to add something to complete the square. So we just did that on the, on the front of this paper. So that's what we have to do. At this point, this is the major, the awesome completing the square step. It's when we're making this a perfect square, so we can simply just take the square root and be done with it and solve the equation that way. So we create this little area here that makes it really easy to remember that when you take this one, divide it by 2, and then you take this number and you square it, and that's what you add to both sides. So you need both of those numbers to help you with this problem. Okay? So remember, to do this, take this number, divide by 2, it goes there, and then square it, it goes there and there. Because whatever you do to one side of an equation, you have to do to the other. So we're making this awesome, perfect square. It's beautiful, but we can't just add the one to this side, because then our equation wouldn't be balanced. All right, so 4 plus 1 is 5. Now we have this great perfect square, and we solve it. So we take the square root. Remember, whenever you put the square root on, plus and minus must appear. All right, so then you have x minus 1. Just make some room here. X minus 1 equals plus or minus radical 5. X needs to be by itself, so I have to move this 1. We generally put the 1 in front because it looks just like the quadratic formula. 1 plus or minus radical 5. So the two answers are x equals 1 plus radical 5 and x equals 1 minus radical 5. Pretty exciting. Okay, so that's the process. The leading coefficient has to be 1. Get letters and numbers to opposite sides. Figure out what you're adding to both sides and what that hidden perfect square is at the same time. It makes life a lot easier. Okay, so let's do it with this one. Oh, excuse me. Let's do it with this one. So with this one, all right, the leading coefficient is 1. Thank goodness, that's done. No dividing necessary. So then what we have to notice is that you have letters segregated there. So we have to move this negative 4x to that side with the x squared. Okay, and the 5 is by itself, so that's good. So to move that 4x, we add 4 to both sides. We get x squared plus 4x. Remember, we're going to add something to it to make it a perfect square. Whatever I add to it, I'm going to add to the other side too. And in the process, I'm creating that perfect square to solve. Okay, so what do we add? So this is going to be x. We have that number, so it's going to be a 2. Remember, divide by 2 to get that one, and then square this one to get that one, and add it to both sides. There we go. We have a great perfect square equation. We're simply going to take the square root. Look at all these colors. So pretty. So take the square root, and we're left with x plus 2 equals 9 is a perfect square. But I don't care that 9 is, well, I care, but the radical goes away. But remember, plus minus 3. You have to do both answers when you take the square root. Then you solve. X has to be by itself. And you have this really bizarre answer, negative 2 plus or minus 3. So negative 2 plus or minus 3, remember, simply means negative 2 plus 3 and negative 2 minus 3. Now we, as people, can figure out what those answers are. So negative 2 plus 3 is 1, and negative 2 minus 3 is negative 5. So we could have factored and t-charted this guy to get an answer, but 1 and negative 5 are our solutions. Well, nice curly brackets. And they asked us to complete the square, so we had to do it that way. So I would, take a second, try to do this one on your own. It's y this time, but it doesn't matter. See if you can take steps to solve it. All right, now I will. I am taking the steps to solve it. I'm looking at this equation. I notice that that negative 5 should be on the other side because the letters and numbers need to be segregated. Yes, we're very terrible at math. We want the letters and numbers separated. So now, I like to do these steps together. We take, it's y this time, so we have to take this number, divide it by 2. Oh no, I divided by 2. That's okay. That's a 5. It really is. My stylus is awesome. So it's 5 divided by 2. Now you can make it 2.5, but again, we like fractions. They're fun. Then we square it, and we add that to both sides. All right? So this is the perfect square. We really don't have to deal with this side anymore. We have it factored already. We're good. So now we have to do this math. All right? Get those calculators out, do something, but get the answers. Negative 2 plus 25 over 4. If you put it in your calculator or find common denominators and add, whatever is your wonderful thing to do, it is 17 over 4. Okay? Take the square root. It's okay if it's a fraction. Try to take a deep breath and just deal with it. You're going to be all right. I know, they stink, but you'll live. Okay, that's 5 over 2. We put the square root on, so we're putting plus or minus. Now I notice that I'm going to look up here, I notice that I can take the square root of 4, but I can't take the square root of 17. So what I'm going to do is take the square root of 4, and once you take the square root, the radical goes away, so it's just a 2 on the bottom, and then the 17 is going to stay. And what's ridiculously easy about this is that I'm almost done. All I have to do is subtract 5 over 2 from both sides. Oh, you didn't see that. I just have to subtract 5 over 2. I shouldn't have put the y there, that's all. 5 over 2 from both sides. And you're basically done. You just have to write y equals negative 5 over 2 plus or minus radical 17 over 2. Now that should look hauntingly familiar, like the quadratic formula. Okay, it is. It's just the quadratic formula. We're just deriving it every time we use it. Fun, wow. Okay, enjoy.